Okay, sorry for the break in the action. This is our last example, so let's make sure we understand what's going on. We've got these two trains, train A and train B, approaching one another. They're currently 550 miles away. Let me put a little MI there, miles away. And then we know that one is traveling at a rate of 35 miles per hour and the other is traveling at a rate of 45 miles per hour. And what we want to figure out or determine is when will they pass each other? When will they pass each other? When will the trains pass each other? So how we can do that is to consider the way that rate, time, and distance relate to one another. And we know that distance is equal to rate times time. Okay, so here's what we're going to do with this concept of rate times time is equal to distance, or distance is equal to rate times time. We're going to set up a little chart. The A refers to train A, B refers to train B, R refers to the rate of train A in this box, and that rate is 35 miles per hour. The rate of the train B is 45 miles per hour, and what we're thinking about here is the time. So I want you to think about the time. How long will it take? You might say you don't know, which is true, but what we recognize is that the time it takes for A to travel to the meeting point and B to travel to the meeting point from their current distance of 550 miles has to be exactly the same, right? So I'm going to put T here and T here, and that'll just be the time. So then when I think about the distance that A travels, it'll be 35T, and then the distance that B travels, it'll be 45T. So what can I do with those two distances that they travel? It has to add up to 550. Doesn't that make sense? So with that earth-shattering news, what we're going to do is actually set up an equation. And really, ultimately, when you set up these charts and you do these mixture problems and these speed problems and all of that stuff, you really are ultimately looking for a way to equate two things. So in this case, we recognize that the distance that A travels, which is going to be 35 times the time, plus the distance that B travels, which is 35 times the time, however many hours they're traveling, has to add up to 550 so they can cover the distance. And that's when they will begin to pass each other. So what we will do is add them together and do what we usually do when we solve these problems. So with 80T here being equal to 550, we can really simply figure out the time by dividing both sides by 80. Of course, this in essence is dividing 55 by 8. We get that these two trains need to be traveling for approximately, hence my wavy line, 6.9 hours, or about 7, probably approximately 7 is better. So almost 7 hours it's going to take for these two trains to eventually meet and pass one another. All right, on to the assignment. Okay, your friends, the assignment is as follows. Pages 136 to 137, problems 7 through 19. Also do 20, 21, 23, and 24. Please be sure to try all of these problems. I know they're challenging, but let's work together on them and you will be awesome and you'll have it handled. Take it easy. Bye-bye.